Hey guys, welcome. Yeah, so problem 5 here, and it's about the monotone convergence theorem. So here's a question. We're given a sequence an where the first term is 1, and the n plus first term is defined recursively as 4 times the nth term divided by the nth term plus 2. Alright, and we're told that the sequence is increasing. And so the task is to prove that the limit as n goes to infinity exists and to find the value of that limit. Alright, cool. So as I said, this is about the monotone convergence theorem. So our solution starts by first writing what we're given for an plus 1, which is that it's recursively defined like this, and then observing that an is bounded. That's to say, if n goes to infinity, this quotient right here, an divided by an plus 2 goes to 1. So as n goes to infinity, a sub n is bounded by 4 times 1, which is 4. And here is where the monotone convergence theorem comes into play, which is if you have an increasing sequence that is bounded, then it converges, and it converges to its supremum, right? And the monotone convergence theorem could be stated for a decreasing and bounded sequence, which is that it is bounded, and decreasing means it converges to its infimum. Alright, cool. Anyway, as we just said, an is bounded, a bounded sequence, and so since it's bounded and increasing by the monotone convergence theorem, the limit as n goes to infinity of an exists, which is that it converges since it's bounded and increasing. And so let's say that it converges to L. Yeah? Okay, cool. So if we say that it converges to L, then the limit is a sub n plus 1 goes to infinity is equal to the limit as n goes to infinity of 4 times this quotient right here, right? And that's because we're told from the start that a sub n plus 1 is 4 times this quotient here. Okay, cool. Now, we said that an converges to L. So this here is L on the left side of the equal sign. And then we're going to see that using limit laws here, we're going to get 4 times L divided by L plus 2. Let's see those limit laws a little bit more clearly. That is, as I said, on the left side, we will have L here. And then I could first take this step, which is to put the constant in front of the limit. And then next is to do the limit as n goes to infinity of the numerator. And the limit as n goes to infinity of the denominator. Yes, I'm being casual, kind of not putting this a sub n plus 2 in parentheses. But you get it. Alright. Anyway, applying the limit laws, as I said, we're going to get on the left side just L. That's from the limit as n goes to infinity of a sub n plus 1. And then on the right side, we get 4 times L divided by L plus 2. Alright. And so this is going to be a quadratic in L. And I'll show you a couple of the steps to the quadratic in L. It's pretty clear that from here, if you solve the quadratic, what you're going to get is L is equal to 0 or L is equal to 2. Now, since a sub 1 is 1, L is equal to 0 cannot be, because a sub 1 is 1 and a sub n is increasing. And therefore, the limit L must be 2. Yeah? Alright, cool. That's it for this video. But problems 6 and 7 to come next. Keep watching. Take care.